Hello everyone, welcome to my channel. In this video, we are going to discuss about what is a runtime environment or runtime storage allocation. So, the basic concept of runtime environment is after writing the program where we need to verify that is there any errors in the program by doing the compiler. That means we have to do the compiler. After that, now the compiler can verify that is there any errors. Okay, it can report the errors to the user. After that, if there is no any errors, then automatically the compiler can generate the object code. Okay. So, now after generating the object code, we need to execute the program, that is called as to run the execute program. Before running the particular program, we need to allocate some memory for the object code. Okay. So, then only we can execute the particular program, otherwise now that program cannot run in the computer system. Okay. The study of the memory allocation in the computer system to execute a program is called as a runtime environment or runtime storage allocation. That means where we have to allocate some memory for the object code in the computer system to execute the program is called as runtime storage allocation. That means let us see the what is the simple what is a runtime environment. A program needs a translation at runtime to implement a program. That program consists of names for procedures, identifiers, etc. that requires memory allocation at runtime. This is called as what is a runtime environment. That means now we can define that what is a runtime environment. That means in the above definition, we must provide the some memory allocation for the program, okay, or other object code. Then only it is possible to execute the program. And what is a runtime environment? Runtime environment is a state of the target mission. It includes software libraries, environment variables and etc. to provide the services to run in the system. So, this is called as what is a runtime. That means it can provide the services to run the particular the program which can be stored in the memory location. Okay. This is called as what is the runtime environment. Now, basically to store the particular program in any one of the place, so we will consider that what is a main memory. That means the main memory can play the very important key role to store the program in any one of the location. So, basically the main memory can be divided into 4 parts. The main memory can be divided into 4 parts. Okay. The first one is code, and next one is static, and third one is heap, and fourth one is stack. Okay. So, once again code area, and second one is static variables or either global variables, that means static memory allocation. The second one is heap memory as well as stack memory. The heap and stack memory can be considered as a dynamic memory allocations. Now, let us see here, we will discuss each and every one what is the main memory code organization, storage organization. So, now the storage organization having the 4 parts. One is the what is a code area. As we know that now after writing the program in the C or other any Java, now those program can be verified by the errors, verified with the for the errors. Okay, is there any errors, then automatically the compiler can report the errors to the users. If there is no any errors, then automatically that compiler can generate the object code. That object code can be stored in the code area. That means once again I am going to explain that what is a code area. Okay. After writing the program, we need to check is there any errors in the given program by doing the compilation. Okay. Is there any errors? Now compiler can generate the errors and report to the users, and if there is no any errors, now that that program can be considered as a object code. That means the compiler can generate the object code without having any errors. That object code can be stored in the code area. Okay. So, that is called as code area. And next one is now there is a static memory allocation. Static memory allocation can be done at the time of compilation. Okay, to verify the errors in the given program where the compiler can use the some memory. That memory is called as a static memory allocation, where we may assign that what is a global variables also to access the particular parameters in the given source program. And next one is the dynamic memory allocation can be divided into 2 parts. One is a heap as well as a stack. Okay. So, that is called as where here this heap can use the some free memory. Okay. In between the heap and the stack there is a free memory. Okay. This free memory can be used by the heap memory allocation as well as stack memory allocation. That means, to understand clearly what is a heap and stack memory allocation, how it can use the free memory, okay, while storing the particular programs in the any one of the location means, now we have a notebook, that is the student have the notebook. Okay. So, that notebook can return one side by the compiler design and one more side can be used by, that is any other subject, that is called as a flat. Okay. So, that means one side can be used for the compiler design and one more side can be used by the flat. Okay. That means, these both sides can occupy the what is a free memory. Okay. So, just like the heap memory can use the free memory here, as well as stack also can use the free memory. Okay. This is called as dynamic memory allocation, where always you have to remember that here the heap memory grows towards the higher address. So, that is called as we know that. So, here, okay, so this is called as higher address and this is called as lower address in the main memory. That means, now the heap memory towards the higher address as well as the stack memory towards the low address. So, that is where grows towards higher address and store the data allocated under the program control. Similarly, what is the stack here? Stack grows towards the lower address, the stack grows towards the lower address and store the activation record. That means, in the stack, okay, in the stack memory allocation, where for each and every function call we have to use one, that is activation record. Now, let us see here how we can create the activation record for each and every function call, okay, in the storage organization.